so like every day she was just giving me just like different pages to like work on.
Okay.
But I understand the other stuff, except the stuff we were working on that last week that we didn't finish. So
you're gonna have to
I was thinking we could.
I've had 20 hours of tutoring since then, so I don't remember what we were working on.
Well, it's in the email from last week.
Okay, I can probably find that. Did you send it or did your mom send it?
I sent it about last week.
MNTW, is that?
No, it's the Emmy Luhu one.
Okay, I've got...
It was probably most recent May 4th. Probably that one.
Which page do we want to open? Left or right? Left got
I think the left. I don't think we finished the left.
Okay.
I think we were on problem. We did 16 because we had to do the reciprocal of the square root of 2 plus 1.
It's not really the reciprocal, it's the conjugate. In other words, we did 16 by multiplying both the denominator and the numerator by the reciprocal of this term.
But we were working on 16 and 17.
Okay. Let's do 17.
Okay.
Well, let's do 16. So I'm going to take 16, hold on a second, and I'm going to multiply it by square root of 2 minus 1 divided by square root of 2 minus 1. Notice we can always multiply any fraction by the number 1, always. And the advantage of doing this is it's going to get rid of the square root. So we're going to have a real number. So let's do the bottom first. What's that give me in the bottom? Don't use your calculator. Don't use your calculator.
4.
Which is a number. Rather than say root 4,
2.
Root 2 times root 2 is 2. In other words, root x times root x is x. So don't expand it and then have to reduce it. And what's the second term?
Minus 1.
So that's the denominator. What's the numerator?
Root 6.
No, it's 3 times that term, which is 3 root 2, minus 3 times 1. So that's the numerator. You don't necessarily have to multiply it out, but since the bottom becomes 1, we end up with 3 root 2 minus 3. And that's our answer. Do you have answers on these?
Yeah, I have the key, answer key.
Just check the key, make sure that's what they give for an answer. They could give a factored answer. In other words, I could factor that out, and it's root 2 minus 1. But I suspect their answer is going to be 3 root 2 minus 3.
Okay.
Is it?
Let me quickly check. Hold on. Oh my goodness. It's in here. Hold on.
If you find it, keep it available, but don't have it open when we're doing these problems. Turn it over on the desk or something so you can't see it.
Okay, I found them.
Okay, what's the answer to 16?
It's 3 root 2 over 2.
3 root 2 over 2.
I think.
I think so. This definitely becomes 2 minus 1, which is 1.
Let me check on the line real quick. I can just click on it on my phone.
Oh, your key is online?
Yeah.
Okay.
That's just what I had written down. I guess I must have written it down wrong.
Well, let's
No, it's 3 root 2 minus 3.
Okay.
So you were right.
Okay.
I must have just written it down wrong.
Okay. Now let's do the second one, 17. Tell me what to write.
So on the top and the bottom, you write 4 plus root 3.
In parentheses. Parentheses are important. Because I have to multiply that term by that term. I'm not multiplying just one term by one term. I'm multiplying a binomial times a binomial. Okay? Well, it's easy enough what we have on the top. What do we have on the bottom?
16 minus 3.
Which is 13. So your final answer is 4 plus root 3 all over 13. And what we've done, notice, is we've turned the denominator into a real number instead of this irrational number. We now have an irrational number in the numerator, but that's perfectly acceptable.
Okay.
Okay? All right, 18. Tell me what.
1 minus root 3 on both the top and bottom.
And when I put parentheses around that, I really need to put parentheses around that, which is rare, but that's really the way you want to do it. Because otherwise you're in danger of just multiplying the root 3 times that. Okay. So what does that give us in the top?
2 minus 2 root 3.
And the bottom?
1 minus 3.
Which is minus 2.
Yeah.
So now we have 2 times 2. Excuse me.
4.
In the top we have 2 minus 2 root 3. And in the bottom we have minus 2. Well, that can be simplified by doing what?
Canceling out the negative 2's.
Well, I know that's a term that I use a lot, canceling out, but really what I'm doing is dividing the top and the bottom by negative 2.
Okay.
Okay, and that's going to turn the bottom into just a 1, which means I'm not going to have a denominator. So if I divide the top and bottom by negative 2, the top turns into a negative 1 plus root 3, and the bottom turns into just 1. So the answer they're probably going to give in the book is either negative 1 plus root 3 or root 3 minus 1. Same answer. Okay.
Okay.
What else do we want to work on here?
We could do just the factoring on the bottom.
Okay, you understand 19 through 22? Pretty good? Let's just go through them all just so I make sure. How do you write x to the 3/4 in radical form?
Root 4.
That's actually called the 4th root, not root 4. It's the 4th root of what?
X to the 3rd.
There you go. that is equal to x to the 3/4. In other words, that denominator is always the root. So that's the 4th root. If it was a 5, it'd be the 5th root, so forth and so on. Okay. This one's the log of the upper number divided by the log of the lower number. By upper, I don't mean bigger. I mean the one that's higher up on the page. Okay. Write in logarithmic form 3 to the 4th equals 81. Tell me what that is in logarithmic form.
Log of 3.
Log base 3 of
81.
Of 81, yeah. Equals
4.
Yeah. In other words, you don't want to say log of 3, because if you say log of 3, it generally means the 3 is in the argument. And in fact, I would have written it like that, common log of 3. So it's always log base, this number, of the argument equals the other. Okay. How would you write that in exponential form? Well, the reason I want to do these is because, boy, if there's two things you have to know in logarithms, it's how to convert exponential to logarithmic and how to convert logarithmic to exponential.
It's going to be 5 to the square root of -2.
Not the square root, just 5 to the -2. Equal
1/25.
Right. And that's not square root. That's 5 to the -2 power. And that is equal to 1/25 because 5 to the -2 is the same as 1/5 to the +2, which is 1/25. Okay. All right.
I just know negative exponents are always fractions.
Here's the thing. Negative exponents never mean negative numbers. And everybody wants them to mean negative numbers. But they don't. They are always just fractions. In other words, it doesn't get any simpler than negative exponents. They're nothing complicated at all. If I want to write 2 to the -3 power, what's that equal to? What's the next way to write that?
1/2 to the 3rd.
Exactly. Now what if I said 1/4 to the -7th? What's that equal to?
4 to the 7th?
Exactly. In other words, whenever you have a negative exponent, you can just put this number on the other side of the fraction bar and change the exponent to positive. It's that straightforward. That's the only thing you ever have to do. Just move it to the other side of the fraction bar. Part of the problem, I think, is there's no fraction bar when you start. In other words, if I'm looking at that problem, I don't see a fraction bar. So I kind of have to put a 1 under it. And now I'm going to move it to the other side of the fraction bar like that. Okay? But it goes both ways. In other words, if I have 1/2 to the -3, I can take that 2 to the -3 and put it in the numerator. Just like that. That's how straightforward negative exponents are. There really is no reason to ever be confused by them. All right, let's do some factoring, because if there's one thing you can never get too much work on, it's factoring. So what's the first step of that first one?
Take out a 3.
Take out a greatest common factor. The number is 3, but there's also a variable that can be taken out.
3x.
That's the greatest common factor, 3x. What's left?
X plus...
Hold on. The way you're going to determine what's left is you're going to take that greatest common factor and divide it into both terms. So what is 6x squared divided by 3x?
2x plus.
Okay, stop for a moment. What you should always be doing on these problems is checking. In other words, once I've written 2x, does that produce that term? Yes, it does. When I multiply these two back together, I get 6x squared. That's what you always want to be doing. What's the second term?
Plus 5.
And again, 5 times 3x gives you that term. And if you're always checking at every step of the way, then when you have a big multi-step problem, you won't know, you'll know exactly where your mistake is. You know, you don't want to do a 10-step problem, get down and find you have the wrong answer and try to figure out where you made your mistake. You'll have to do all 10 steps over again. So it's always better to always be checking at every single step of the way. Okay. Okay, how about 24?
Well, it's perfect squares.
Okay, so factor it.
8. I don't know how many.
Okay, here's how to do this. Here's how to do this. We know that a squared minus b squared is equal to a minus b times a plus b. We're looking at that. We just have to figure out what a is. Well, notice that a is the square root of the term on the left. So what's the square root of 64x to the fourth?
B squared, or I'm sorry, 8 squared?
8x squared. Notice that if you square 8x squared, it's 64 times x to the fourth. What's b?
8x squared.
Hold on. B is the square root of that.
Oh, 5x.
It's not x, it's y.
5y squared?
No. When you
To
take
the third?
square root, yeah, when you take the square root of a variable, you basically divide that exponent in half. And the reason is that if I multiply y to the third times y to the third, what do? I add the exponents. So if I'm taking the square root of y to the sixth, it's taking half of that exponent. Okay, so now that I know what a and b are, the problem becomes relatively straightforward. So what's it become? We know it's a minus b times a plus b. So fill it in.
8x squared minus 5y to the third, and then 8x squared plus 5y to the third.
I can't really do anything with that. I can't keep factoring. Sometimes you can keep going if it's the right numbers. In other words, if one of these ended up being another difference of perfect squares, you could keep factoring it. But it's not. Neither one of them has a greatest common factor, nor is either one of them difference of perfect squares. So we can't do much more with that. Okay, how about 25?
I don't know. I think I'd have to... I don't know if 4 goes into 81, does it?
It does not. For one thing, 81's an odd number. For something divisible by 4, it's got to be an even number. It's like being divisible by 2. Only even numbers are divisible by 2. Well, if something's not divisible by 2, then it's not going to be divisible by 4.
Yeah.
Okay.
I know 9 goes into 36 and 81.
Well,
but not 4.
That's kind of getting ahead of ourselves. Let's factor this in a normal way. In other words, you're kind of trying to do the whole thing all in your head. Let's start with step 1. Let's split apart the 4x squares. What's the most likely way they're going to split apart?
By
either 2x times 2x or 4x times x. In other words, you always split the x's up 100% of the time. Okay?
Okay.
So which is the most likely one? Is it going to be 2x, 2x, or 4x and x?
2x.
Yeah, always the ones that are closest together. 2 and 2 are closer together than 4 and 1 are. So we're going to start there. And it's important to understand this is a trial and error process. There is no computer algorithm that'll give you this. There might be, but I don't know what it is, and they don't teach it. When you're factoring something, it's a process of steps, and you don't want to get ahead of yourself. The biggest mistake I see students make, they try to come up with the answer all at once, and then they keep trying various combinations of it. And that's not the way to do it. The second step is what? Very important second step that everybody wants to overlook.
Take out the...
No, determine both signs. What do both signs have to be?
Positive and
No,
negative?
if one was positive and one was negative, I could never produce a plus 81. The only way you can produce a plus 81 is if the signs are the same. They either have to be both negative or both positive. What are they going to be in this case?
Negative.
Because the middle term has a negative on it. So we know this much. Step 2 complete. Now, factors of 81 are actually pretty easy because there are not very many of them. There's 81 and 1. That probably isn't going to work. But there's 9 and 9.
Well, 4, 36, and 81 are all perfect squares.
Okay. Which set of factors is most likely to be the correct answer? 81 and 1 or 9 and 9?
9.
Okay. Now all we have to do is check and see if that produces the right middle term. We know it's going to produce the 4x squared. We know it's going to produce a plus 81. So does it produce minus 36 as a middle term? And remember how you get the middle term. It's from the insides and the outsides only. When you multiply the insides together, you get minus 18x. You multiply the outsides together, you get minus 18x. That adds together to minus 36x. That is our middle term. We've factored it properly.
Okay.
Okay, and to me, that's the way to do it. You are correct that 4, 36, and 81 are all perfect square numbers. I'm not sure I know what to do with that. Maybe your teacher has taught you that when you have all perfect square numbers, there's a secret little technique to use. But don't really need it on this problem. This was not a hard problem. In other words, step 1 was really easy, and 2x ended up being correct. Step 2 was super easy. Both signs have to be negative. And step 3, you're never going to use 81 and 1 unless there's a huge number in the middle. But 9 and 9 are the only factors of 81. It turns out that's the correct answer. All right. Let's go to the next one. 4x cubed plus 32. It's a good first step.
Take out 2.
Take out the greatest common factor. Always the greatest common factor.
Oh, 4.
Okay. Leaving?
X cubed plus 8.
So now, what's that called?
I don't know. I don't remember.
Sum of perfect cubes. In other words, here, let me go over these because there's a particular way to memorize these that is more helpful than some others. I notice a lot of my students make, when I ask them what the difference of perfect squares is, they give me a plus b times a minus b.
Mm-hmm.
I don't like that answer, and I'll show you why. It's a minus b times a plus b. And you say, well, that's the
Mm-hmm.
same answer. Well, watch what happens. Difference of perfect cubes starts out with that same linear factor. Second one is a squared, opposite sign, ab, always plus b squared. And then when
Mm-hmm.
you have the sum of perfect cubes, there is no sum of perfect squares, incidentally.
Mm-hmm.
The only ones you can ever factor are the sum of perfect odd numbers. First term, same sign, also linear, like that. Once you figure out the first term, the second term kind of writes itself. What's the second term going to be?
A squared minus
Opposite sign, correct?
AB minus
It's
B cubed.
always plus. The b squared is always plus, regardless of whether you started out with difference of cubes or sum of cubes. Okay?
Okay.
Now look at these three, and notice how easy it is to remember. That is a linear term with the same sign as what we started with. That's a linear term with the same sign as what we started with. That's a linear term with the same sign as what we started with. The next term is just the opposite sign. This you kind of have to memorize, but it's still, the middle term is the opposite sign of the first term. And the third term, it's that same term, only the middle term is the opposite sign of the first term.
Mm-hmm.
So memorizing these is actually relatively easy. These are not hard to memorize as long as you memorize them in a certain pattern. And this is why I hate the answer that the first one is a plus b times a minus b, because it messes that pattern up. You know what I'm saying?
Mm-hmm. Yeah.
Okay. So, knowing that, hold on. What happened to let's see. I want to do this. So number 27, we're starting with 4 times x cubed plus 8. Now, do you see why that is the sum of perfect cubes?
Yeah, I think so.
8 is a perfect cube number. It's 2 cubed.
Yeah. Mm-hmm.
Okay? So my a is x, my b is 2. In other
Mm-hmm.
words, a is always the cube root of that, and b is always the cube root of that when you're dealing
Mm-hmm.
with sum or difference of perfect cubes. So now what does it become? 4 times, there's 2 terms. What's the first term going to be? Remember, it's a linear term
X.
with the
X.
same sign as what you started with.
So X plus 2.
Good. Now the second term. Remember, this term is a squared.
So X squared.
The sign of the middle term is the opposite of the sign of the first term, or what we started with. So it's got to be minus
Minus 2 squared.
2x. AB. That's all it is. The middle term is AB. Plus, it's always a quadratic, so there's always a constant. B squared. See how I got that?
Mm-hmm.
That's a squared minus ab plus b squared. is what that is.
Mm-hmm.
Okay? Now,
Okay.
in case you're ever wondering, that never factors. After you've done the sum of perfect cubes, the quadratic term that you end up with never factors. That's a quadratic term. That's linear, that's quadratic. You don't need to waste any time trying to factor the quadratic. It will never ever factor. Not if we've started with the sum of perfect cubes or the difference of perfect cubes. Either one, it'll not factor. Okay?
Okay.
Okay. Now, let's do 28. Usually when you have a complicated thing to factor, it's not always, but most of the time it's correct to take out a greatest common factor. Always start there. So what's the greatest common factor?
Just 8.
Leaving?
X to the 6th minus 8y to the 3rd.
Okay. Now, what's that? It's the difference of something, right?
Of cubes.
Okay. So what's my A?
X.
No. What's the cube root of x to the 6th?
X to the 3rd.
No, x squared. If I take x squared and cube it, I'm adding all those exponents together, I get x to the 6th. So if I'm taking the cube root of x to the 6th, I get x squared. In other words, when you're taking the cube root of stuff like this, what you're doing is just dividing the exponent by the cube, by 3. Okay, what's b?
2.
2 what?
Cubed.
No, it's 2y.
Oh.
In other words, that is b cubed. So if I want to figure out what b is, I got to take the cube root of 8y to the 3rd, which is taking the cube root of 8, which gives me 2. And to take the cube root of y to the 3rd, I divide the 3 by 3, I get y to the 1.
Wait, say that again?
To take the cube root of any exponent, let's say I had y to the 12th, and I wanted to take the cube root of it. Well, basically, taking the cube root is doing that, correct?
Yes.
Okay, which is dividing 12 by 3. In other words, I'm now going to multiply 1/3 times 12, so I'm going to get y to the 4th. That's the cube root of y to the 12th. So it's really just taking the exponent and dividing it by 3, just like the square root is taking the exponent and dividing it by 2. Okay. So, let's see, where are we at? Okay, so now our answer is 8 times what times what?
X squared plus
It's always that first term is the same sign.
minus 2y. And then
What's a squared going to be?
x to the 4th.
Okay, what's the sign of the next term?
Plus
Okay, what's the next term?
2y.
AB. The next term is A times B.
2xy squared.
No, x squared y. They're not the same. 2xy
Okay.
squared is not the same as 2x squared y. Okay? So you got to make sure that that's A, that's B. Well,
Okay.
that's not B. B is 2y, but that's how I got the 2 in front. And then the third term is b squared. What's b squared? And it's always plus, no matter whether I started with the difference of perfect cubes or the sum of perfect cubes. This third term is always plus, and it's b squared. What is b squared?
2y squared.
Like that?
No.
In parentheses.
4y.
Right? Okay. So you've got to remove the parentheses, which becomes 4y squared. So there's our answer to number 28. And again, don't worry about trying to factor that further. That's not going to ever factor further. All right. 29. I presume the ones crossed out are ones you don't need to do, huh?
Yeah.
Okay. Well, 29 is pretty straightforward.
Take out the x.
Okay. Do it step by step.
Plus.
Both signs. Both signs. Always both signs. Don't ever figure out one sign at a time. That's a recipe for disaster.
Well, they're both going to be positive.
Okay. Then say plus plus. Yeah. In other words, there's two signs that have to be figured out. They're either plus minus, minus plus, plus plus, or minus minus. So that's the answer you need to come up with for step 2. Is which of those 4 are they? Okay, we got that right. Now, what's the third step?
5.
Yeah, in this problem, I can actually say factors of 25 that add, because of that plus sign, to the number 10. Well, that'd be 5 times 5. And there's no question about which one goes where. So this is as simple as they get. This is a 3-step factoring problem. 3 and only 3, and there's no trial and error even. In other words, when I have a straightforward one like this, then it's always factors of that number that either add or subtract, depending on whether that's a plus or a minus, to this number. Okay. 30.
I don't even know where to start on 30.
No, I know where to start. I'm just trying to figure out if I need to move it to my right. It's 2 minus 6 plus 1 minus 3. I think I do want to move it. Here. It's 2x cubed minus x
6
squared, go ahead, plus
x minus 3.
Okay. This is a cubic equation. Okay? Those do not factor easily. They factor with extreme difficulty, except about 1% of the time. And 1% of the time is if it can be solved by grouping. And this one can. And the only thing that has to be true is that the coefficient 2 over minus 6 has to be the same as the coefficient 1, the number that's in front of the x, over minus 3. If
Mhm.
those two ratios are the same, then it can be solved by grouping. And they are. And in fact, you know they're going to be because they have not taught you the hard way to do it. In other
Mhm.
words, you only have one way of factoring cubics, and that's by grouping. So you can always bet that if they give you a cubic to factor, and I can't take a greatest common factor out of that, then it's going to be solvable by grouping. And basically
Mhm.
grouping does this. You group the first two terms together, and you group the last two terms together, and
Mhm.
I can only do that because they're being added. If they were being subtracted, it's a lot harder problem. You know,
Mhm.
I don't know. Maybe we don't need to worry about that. But now what you do is you take a greatest common factor out of each one. What's the
Mhm.
greatest common factor out of the first group?
Uh, 2x squared.
What's left over?
X minus 3.
And then I got an x minus 3 over here. Well, the next thing we're going to do is something that you rarely do, which is to factor out a binomial term.
Mhm.
Notice most of the time you factor out a greatest common factor, it's a monomial term like 2x squared. It's
Mhm.
very rare where you factor out a binomial term. But I got a binomial term in that end and I got a binomial term there. So I can factor out an x minus 3.
Mhm.
What does it leave? Remember how you get what is left. You divide both terms by what you factored out.
Well, are you taking one of the x minus 3?
Huh? Yeah, and here's what I'm doing. I am factoring out an x minus 3 from that end of the term and also from that. Remember what factoring out is. You're just dividing both terms by x minus 3.
Mhm.
So what I'm really doing is I'm dividing that term by x minus 3, and I'm going to divide that term by x minus 3. And
But then
whatever
it's
this
just
is what's left. What's left?
2x.
Squared
Mhm.
plus
Minus plus 9?
plus 1.
1.
You see why?
No.
Well, x minus 3 divided by x minus 3 is 1.
Okay.
Remember, that's what that term is your first term divided by x minus 3. This term
Uh-huh.
is your second term divided by x minus 3. If I were to multiply these two things back together again, I would get what we started with. That's what factoring is the reverse of foiling. It's just very unusual that you ever factor out a binomial term. When I say
Mhm.
binomial term, that's a binomial term. It's got two terms in
Mhm.
it. That's what you're not used to doing, is factoring out a binomial term. Well, when you factor out either a monomial or a binomial term, what you're doing is this. I'm really dividing that whole term by x minus 3, and I'm going to divide that whole term by x minus 3. And then the x
Mhm.
minus 3 goes there, and what's left is whatever you get when you do that. Well, that's 2x squared, and whatever I get when I do that is plus 1. And there's my answer. I have factored the cubic.
Okay.
The only reason I could do it was because of those ratios were the same. Now, by that I mean change that number to a 2, can't do it. Cannot solve
Mhm.
that. Cannot solve it by grouping. Change that number to a plus 3 instead of a minus 3, I cannot do it. That ratio has to be exactly the same. And in this case, with what you're looking at there, I got 2 over minus 6 is not the same as 1 over 3. So the only reason it worked in the first time was because that was a minus. Now, if this is a minus instead of a plus, you got to be very careful. But I don't know that we should spend our time figuring that one out, since that's not on your review material. They gave you an easy one, not a hard one. But if that middle term is a minus, it kind of changes everything. All right, so I guess I want to go to the next page, huh?
Yeah, this is word problems.
Okay, that's fine. Those count just as much.
I want to do not the probability one, because those are easy.
Okay, which one?
But the variation ones.
Okay, you're good with number 40 also?
Maybe we should do that one.
40 is actually pretty easy.
Okay.
All the numbers multiplied together.
Oh, really?
Yeah. This is a very common question on the SAT exam or the ACT exam. Usually it's a little simpler. Usually it's, I got excuse me, hold on a second. Let's say I've got a wardrobe that consists of 3 shirts, 2 pair of pants, and 4 pairs of shoes. How many wardrobes can I make? 2 times 3 times 4.
24.
The point is that it's always this number times that number times that number. Whether it's 3 different types of clothing, or in this case, we got 9 shirts, 6 pair of pants, 2 belts, 5 hats, and 7 pairs of shoes. So how many different outfits can I make? 9 times 6 times 2 times 5 times 7. It's that straightforward. Now, not all problems are fit this. In other words, just because you see a combination problem doesn't necessarily mean it's going to be the product of all the numbers. They can get a lot harder, but this is your most basic kind. If you run into a problem like this and you're not quite sure what to do, then guess that the answer is the product of all the numbers.
Okay.
Okay? Now, varying. If I say y varies means equal. If it's directly with x, first of all of these problems have a k. That is the first thing you want to write. Okay? If y varies directly with x, that's the equation. If y varies inversely with x, I still have a k, but the x goes there. If y varies jointly with x and z, I still have the k. Jointly means directly, basically. And if y varies inversely with x squared, I would write it like that. So all of these you can figure out. This one is very straightforward. It just says y varies directly with x. And they're going to give you a y and an x. That's going to allow you to solve for k. And that's the way you do all of these problems. So I plug in 15 for y. Always trying to solve for k, because we never know what k is when we begin. So when I solve for k, I get 15 divided by 12, which is the same as 5/4. Now I know my specific equation. My specific equation is y equals 5/4 x. In other words, once you've solved for k, you now have an equation that will answer any question. And their question is, find x when y is 30. Okay, so let me erase this. Find x when y is 30. Solve that equation for x when y is 30. Tell me what to write.
Do you multiply?
First of all, substitute. When y is 30, let's put 30 in for y.
Mm-hmm.
Now it's getting simpler. Now we start to solve for x. How do I solve for x?
Well, don't you just multiply 4/5 by both sides?
Good. Yep, you multiply by the reciprocal of that coefficient. You could do it in 2 steps. That's the one-step method, and I like it. So x ends up being 24. Those always cancel when you multiply by the reciprocal.
Mm-hmm.
And that becomes 6 times 4.
What's the 2-step process?
Good question. For some reason, a lot of people don't like that one-step process. The 2-step process would be multiply both sides by 4, and then divide both sides by 5.
Oh.
Notice that's exactly what you do in the one-step process. Is you multiply both sides by the denominator and divide both sides by the numerator. That's the same as multiplying by the reciprocal. Multiplying by 4, dividing by 5.
Okay.
So I prefer the one-step process, but a lot of my students can't remember it. But they always can do the 2-step process. In other words, the 2-step process is what you would normally do. Get rid of the denominator and then get rid of the coefficient.
Mm-hmm.
All right, let's see. 42. The volume of gas varies inversely with the pressure. Don't let the complexity of this or the fact that it's a physics problem make it more difficult. It really is not.
Mm-hmm.
Let's write the general equation, and then we'll figure out the specific equation. So volume is V. What does varies inversely with pressure mean?
Divided.
Well, hold on. We need a K. Don't forget the K, because the K is the first thing we got to solve for.
Mm-hmm.
So there's our general equation for Boyle's law. As long as the temperature of the gas remains constant. Okay?
Mm-hmm.
Now they're going to say if the volume of the gas measures 3.1 when the pressure is 1.3, that's going to let us solve for K, right?
Mm-hmm.
So let's do it. Tell me what to write.
So 3.1 is V, which equals K over 1.13.
Just 1.
And then you...
1.3, right?
No, it's 1.3, I think.
No, it's this one at the moment. That's for the second part of the question.
Ew.
Okay? In
And
order
then you
to figure out K, they're always going to give you a V. In other words, they're going to give you all the variables you need to solve for K, which is 2. They got to give you a V and a P, which will let you solve for K. So K is equal to 3.1 times 1.3, which is what?
Let's see. I can't do that at the top of my head.
You should have a calculator in front of you. Do you have a calculator?
Yeah, I do.
Do it on a calculator.
4.03.
Okay. Now, what is my specific equation for Boyle's law?
Inversely?
Well, let's start with, in other words, this is the general equation. We just solved for k. So now let's write the general equation only with the known k that we have. So
well, it'd be 4.03 divided by 1.3.
No, divided by p. That's the specific equation.
Yeah, so 1.13.
Hold on. Yes. The thing is that I want you to understand is that equation governs all questions they might ask. They might say, well, what's the volume when the pressure is 3? So you need this equation. That is the specific equation. Their question now is, what is the volume when the pressure is 1.13? So V equals 4.03 divided by 1.13. And whatever that is your answer. But it's a very standard methodology. All of these varying problems are all the same. You write the general based on their wording. Then you solve for k, always, based on the fact that they give you a v and a p, which lets you solve for k. Then you go back and you write the specific. What I've check marked over there and circled on the left is the specific equation for this problem. Not this problem, but Boyle's law. And you could figure out the volume given any pressure they give you. They're giving us a pressure of 1.13, so we're going to divide 4.03 by 1.13. But they might have given us a different pressure. They could ask 3 more questions about this with 3 different pressures. They might even give you a volume and say, what's the pressure given that volume? But this is the important equation on the left there. You don't want to just always skip to that. You want to do it methodically. Write the general, solve for k, write the specific, and then answer whatever question they're giving you. Okay, Emma, I got a 5:30. I got to run.
Okay.
So,
my mom will pay you, I guess, through the...
I sent her an invoice this morning through today, through your completed session today.
Okay.
Okay, and you probably are done, right? You're not going to need any more tutoring, at least.
Yeah, I mean, unless I end up having to take this in college.
Well, or if you end up taking math over the summer or something. My rates go dramatically down in the summer. So between June and September 1st, my rates go from like 32 an hour to 20 an hour. Okay? But then next year when you are in college, yeah, as long as we're doing it online, it doesn't matter where you're at. Where are you going to college? You're going in Denver.
I'm just going to Metro for a year to get my basics.
Okay.
And then I'm transferring to CSU.
My guess is you're going to have to take math next year.
Yeah, I mean...
some kind of math.
Yeah, I'm probably, from what my degree I need up to, like, statistics or so.
I don't do statistics. So if that's what you're taking, I'm not going to be an option for helping you. Just because I don't have expertise in it.
Yeah.
I can do basic statistics that people take, in Algebra 2 class, but if you're taking a statistics course, I'm not going to be of any help.
Yeah, I'm not sure what I'm doing yet.
Here's one thing I know almost for sure, and that is that you're probably going to have to take the math placement exam, are you not?
Yeah, I do. No, actually I don't.
I can help you
don't.
a lot with that, and that includes quite a bit of math that you haven't had yet.
Oh,
In
I
other
scored
words,
enough. I scored high enough on the math ACT, surprisingly.
oh, that they don't make you take the MPE. Well, good.
No, I
Good.
scored a I scored a 25 on the math.
Well, good for you, Emma.
Somehow.
That's a good score. That's
Yeah, somehow.
average is
I
20.
don't know how I managed to do that.
Well, you must have learned it.
Must have. Well, thank you.
You're welcome. You have a good time, and like I said, if I can be of any assistance in the future, let me know.
All right, thank you.
Okay, Emma. Bye-bye.
Bye.